Hi all, a very warm welcome to the course for Probability for Computer Science. As we know in IIT Kanpur, this is known as CS203. This is the first introductory lecture. Today, we are not going to talk about anything technical, but just give you an introduction about the course. That means what will be covered and why is it important for you. All the information about the course will be present on the course web page. These videos are just for the help. I think a much better resource would be the course notes. So ideal thing would be that you look at the course notes and these videos simultaneously. All this can be found on the course web page. I will give the link at the accompanied YouTube information. If not, you can just search my name and probability course IIT Kanpur on Google, and you should be able to find the course web page. This is the course web page for course CS203. There you will find demos also, notes also, which are important. Starting with the course, why do we need to learn probability? Now, I would say that for most of the computer science people, this might seem like a moot question. Obviously, probability is very, very important. There are so many areas. You have statistics, you have physics, you have quantum mechanics, very, very important fields of science where probability forms the backbone of these fundamental theories. And now, with the advent of AI machine learning, you see that probability is everywhere. Actually, in almost all areas of computer science, you need some background in probability. And if this does not motivate you, there is always gambling. So if you want to make quick money, I'm not supporting that, but yeah, that definitely requires probability. And historically, probability started because people wanted to gamble. So they developed the theory of probability to smartly gamble. Anyway, we will learn it because of similar reasons. I'm almost sure that you were introduced to probability in high school, right? And you have calculated probabilities of events like when you toss a coin, can you get two heads in succession? What is the probability? You throw a dice, and what is the probability that a prime number shows up? Simple questions like that. So your question might be, oh, I already know the probability. Why do I need to learn more? The main objective of this course is to develop a solid framework to tackle all these questions. And not just these questions, but talk about many more advanced questions. What kind of questions are we interested in? Let's take a look. We will start slow. First question could be, you roll two dices. What is the probability that the outcomes you observe on the two dices are co-prime to each other? Again, since you have taken a course in probability, this is not a very difficult part. You will see that there are total 36 possible outcomes, 6 times 6, and then a simple counting will give you number of favorable outcomes. That means the outcomes where both the things are co-prime. I will not give you the answer. You should probably do this exercise and make sure that you can get this answer. This was not very difficult. So let's talk about this question. Suppose you have a circle and let's take an equilateral triangle inside this circle. Pardon my drawing. We will assume that ABC is an equilateral triangle. So all the sides are equal, angles are 60 degrees. Now you draw a random chord. So you pick a random chord inside the circle, and the question is, what is the probability that the length of the chord, the one which you have picked, is more than the side of the triangle, right? So you have length of AB, BC, CA, all of them are equal. So you want the probability when you pick a random chord that the length of the chord is more than side of the triangle. You might want to give it a try. I will just show you some of the approaches. Now the first approach could be that you pick two endpoints. Without loss of generality, fix one at A. And now the other point of this chord can vary from anywhere up to here. And you realize that the length is more only if the endpoint lies between B and C. So this tells you that the probability is 1 by 3. Seems this question was not hard. But let's take another approach. We know that the chord on a circle is defined by its center. Where should the center lie so that the chord has length more than the side AB? And you will see that this happens only if the center lies in this smaller circle. I will not give you the details, but you can check that the radius of this circle is going to be the half the radius of this bigger circle, and that means the probability will become 1 by 4. So when the center lies in this circle, then the chord is bigger, otherwise smaller. What happened here? The answer came out to be different. We can also define the chord by its distance from the center. Now, by a similar argument as in the previous case, the distance of the center should be less than r by 2. So the distance varies from 1 to r. If the distance is less than r by 2, then our chord is bigger. So that will give you a probability of half. So we got 3 different answers. Which one is correct? This might be a question in your mind, and I will let this be a question in your mind.